And if you want to maximize your grade, what would you have to do? I'll show you how to maximize other things, but minimize your social life. That's unfortunately probably true. Look at the key. Where's Key Boy? Is he here? Okay. All right. Okay. Sorry, Tyler. I didn't mean that. Okay. So how to maximize our grades. I want to show you guys a picture here. These are some chickens that can help you get some grade A's. Haha, okay. Not all of you got it. Okay. What are we going to do today? We're going to have my math lab assignment. You're not going to have time to do it in class anyway, but I'm going to do as many problems as I can with you, okay? This unit is like related rates, all right? There's a bunch of word problems, okay? I don't want you to get behind. We're going to go, I'm going to say fairly fast, but it's not super fast. It's just if you don't do your homework one night, it's going to turn out to be a lot, Maddie, okay? So what you want to do is do 8 problems tonight on your My Math Lab. She doesn't even listen. Okay, 8 problems tonight on My Math Lab. Okay, and then tomorrow we'll do just 9, 10, 11, 12. So just 4 problems tomorrow, and then 4 problems on Wednesday, okay? And we're just doing a little bit at a time. The problems get a little harder as you go along, but kind of like the related rates problems, we'll do it together, and then you'll have homework that looks just like it, okay? Your test will be the problems from your homework, so it shouldn't be hard, okay? The only terrible thing is I'm gonna pull in a motion problem with it, okay? Because you just did motion, right? And we're gonna have a semester final next year, not this year, okay? And so it'll be like a year-long final. And I don't want it to feel over like too much when we do the review, all right? So I'm gonna pull in a motion problem because motion is fairly recent with you guys. And motion is basically maximizing and minimizing. Okay, so let me show you what I mean by that. Okay, so let's look at your notes, okay? And we're gonna do this problem, and your notes say we're gonna do it 2 ways, but we're actually just gonna do this problem 1 way, okay? And it's the way that you guys did it when you guys learned how to maximize and minimize velocity. So here, what am I asking you for? I give you a position function, okay? So this is a position function. And I ask you to minimize velocity, okay? And some of you guys had trouble with this on your test, okay? And the reason was, instead of minimizing velocity, you minimize position instead. Okay, what do I mean by that? If you're asked to minimize velocity, what you need to do is get a V prime number line, okay? And you want to minimize velocity. So you need your pictures. If this is F prime, remember this is F, right? So if this is V prime, then this is V, okay? So you need to get a V prime number line, set your V prime equal to 0, find out what your time is right there, okay? And do your plus, 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 minus, 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 all right? So if V prime is equal to 0, the first thing I need to do is find V prime, okay? So if this is S, first I'm gonna find S prime. So S prime is equal to 3t squared minus 10t plus 12. Do you agree with that? Okay, what a lot of you guys did on your test was you set this equal to 0 and you put this number right here. And actually, I guess you got 2 numbers, which is incorrect because this is not V prime. What's another name for S prime? This is actually V. So you had to take the derivative again, okay? So when you take the derivative again, you'll get 6t minus 10. And that is your V prime. And so when you set this equal to 0, okay, you get the critical points, right? You'll get 6t is equal to 10. So therefore, t is equal to 10 over 6, which is 5 over 3. So your t right here was actually equal to 5 over 3. Okay, so once again, those of you guys on your test that didn't take the derivative twice, you actually ended up with the wrong critical points here. Okay, so this is my V prime critical point. Then what I want to do is get plus, 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 minus, minus, minus. Well, what is V prime equal to? Well, V prime right here is equal to 6t minus 10. And you have a calculator, so you can put it in your calculator. I'll put it in my calculator, but this is something that I can do without my calculator, okay? So I'll put this in my calculator. I'll say this is 6t minus 10, so that's 6x minus 10. And I'm actually pretty bad at my calculator, so I don't know how to delete things. Like, how do I delete that squared? Oh, and I press delete. Okay, that was frustrating. No, it's still there. How many times do I have to press it? Okay, okay, 6x minus 10. All right, so so then I graph it. Okay, So do you see this graph is the V prime graph? Where V prime is equal to 0, that's going to be my 5/3. Does that make sense? Right there. So to the left of 5/3, V prime is negative, right below the x-axis. To the right of 5/3, V prime is positive. So you can look at your graph and go in here and say, oh, that's negative, negative, positive, positive, okay? Well, when V prime is negative, then V must be decreasing. When V prime is positive, then V must be increasing. You guys know this, right? Because F prime is positive, F is increasing. When F prime is negative, F is decreasing. Well, if V is decreasing here and V is increasing here, and this is the only critical point, okay, then whatever the graph looks like for V, it's probably a parabola, right? It probably looks like that. Then this must be the minimum, right? That must be the minimum V. And if that is the minimum V, let's go find the question. The question is, find the minimum velocity and the time that it happens. The time that it happens is at 5/3. And how do I find the minimum V? How do I find the minimum V? You plug it in. So V at 5/3 is equal to question mark, okay? Well, go find my V. Now be careful. My V is not 6t minus 10, right? What is my V actually equal to? Right here, yeah, 3t squared minus 10 plus 10t plus 12. So I can go put that into my calculator. Okay, so at y1, I'm going to put in 3x squared minus 10t minus 10x, okay, plus 12. Okay, that's my V. I want to plug in 5/3 into that V. So I'm going to hit second quit. Okay, I'm going to pull up my Y1. Do you remember how to pull up your Y1? Alpha, trace. Do you remember that? Pull up your Y1. Okay, what am I going to plug into that Y1? 5/3. So you can open up your parentheses. Okay, put in 5 divided by 3. Oops. 5 divided by 3. Close your parentheses, and bam, like it tells you the answer, which unfortunately was different from my answer in fourth period. Okay, well, assuming that that's right, okay, then my velocity is going to be equal to 3.666 or 3.667. You can truncate or you can round correctly. Both are acceptable answers. I have a feeling I plugged into V prime in fourth period. You got the same answer I did right here? Okay, then that's good. Well, it just means fourth period got the wrong answer and nobody said anything. Okay, so that is my minimum velocity. Any questions about how to find minimum velocity? Okay, the way you justify it is you'll say, and you guys don't have to justify this, but I just want to let you know in real life, okay, you would have to justify this because whenever you set something equal, the derivative equal to 0, you could have a maximum or you could have a minimum. Does that make sense? Let's see, how do I know that? Because slope of 0, superhero, right? Relative max, relative min, horizontal tangent line, okay? So you could have a maximum, you could have a minimum. If you only have one critical point, it's going to be the absolute max or the absolute min, okay? In real life, you should test it. When we do optimization problems, they're going to be specially concocted so that if they ask you for a minimum, you're going to calculate the minimum. If they ask you for a maximum, you'll calculate the maximum. I'm just letting you know. But in real life, you should test it. So let's move on to optimization and to help you understand what we're doing. What is optimization? Okay. Optimization is, there's this word that I'm trying to, I can't find it. Okay. Optimization is when you're trying to maximize or minimize something, and it happens in real life. And the best example is the airline industry, okay? If you think about United Airlines, they are trying to maximize profit. You agree? They're trying to maximize their profit, but they've got a whole bunch of constraints that they're trying to work against. They've got to make sure the pilot is on the right plane, right, in the right city at the right time, right? They've got to also satisfy all their customers. So if the customer wants to go from Houston to Singapore, okay, they've got to make sure that they can get them in the right connections, and the pilots are on those same connections. Does that make sense? At the same time, the flight attendants need to make the right connections. Does that make sense? There's like a lot of constraints they're pushing together to make sure that they maximize profit, okay? United doesn't only maximize profit, they actually maximize, they actually minimize accidents, right? They don't want any accidents. So at the same time they're trying to maximize profit, they're minimizing accidents, okay? The problems that we're gonna do, we're only gonna maximize one thing or minimize one thing. But in real life, guys, United has a giant computer program that is full of derivatives. Is that cool or what? Okay, it's full of derivatives so they can maximize and minimize things, okay? And if you guys like this maximizing and minimizing stuff, as you guys go look for a job, it's an area called logistics, okay? That if you actually like it, it's actually a good area to go through. It's a lot of logic. That's also very interesting. How do they build these computer programs to maximize profit? Okay, so let's go ahead and look at an easy example, okay? And this is an example that says you have two positive numbers, okay? Let me just call those numbers X and Y. And so this, just like related rates, you're gonna have to think of your own variables, okay? The sum of these numbers is gonna be 20, but you want the product as large as possible. So what are we trying to maximize? The product, okay? And I need to know the formula for product, okay? Just so happens I know the formula for product of two numbers. It's X times Y, okay? So I'm trying to maximize the product. And so this equation, there's another name for it, but this is your optimization function, but there's another name for it that I can't think of. So you're trying to maximize this. So what you're gonna do, just like when we try to minimize velocity, you're gonna take the derivative of it, you're gonna find the critical points. So you're gonna take the derivative, you're gonna set it equal to 0. And the maximum or the minimum is gonna happen at that critical point, okay? So the question is, when I take the derivative, I have lots of questions actually going on right now. Do I take the derivative with respect to X? Do I take the derivative with respect to Y? Okay, do I take the derivative with respect to time? Okay, now this is just like your related rates problems. In your related rates problems, I don't know, you probably flushed it out of your memory, because I know after you guys take a test, it's like it blows out of your ear basically as you guys walk out of the room. But you took the derivative with respect to time in related rates, okay? Now we're not dealing with time anymore, okay? We're just saying, what's the maximum X or the maximum Y or the maximum product? So what we're gonna do is we're gonna take the dx, and you could choose dy, it doesn't matter, okay? But one of these variables, you're gonna take it of both sides. But what you notice is if you do that, do you see you have implicit differentiation going on? So we're gonna avoid that like the plague here if we can, okay? And so to avoid that, what you're gonna do is get a constraint equation, okay? And in real life, you have a lot of constraint equations. And my constraint equation, see if this makes sense, is given to me right here. X plus Y is equal to 20, okay? So what you actually essentially have is two equations, two unknowns, okay? All right, not quite, but kind of like that, all right? And so this is gonna help me take this into one variable. So what I'm gonna do is I'm gonna take the derivative of this side. But before I do that, I'm gonna move my P, okay, into just one X or one Y, okay? So this X, I'm gonna solve, it doesn't really matter what you solve for. So let me solve for X here. Do you see that X is actually equal to 20 minus Y, right? Because that's my constraint. X always has to be, X plus Y must always be 20, okay? So if that's true, then over here, wherever I see an X, I can replace it with 20 minus Y, and then times Y, that Y is still there, okay? So then what you're gonna do, remember when we took the minimum velocity, we took the derivative of velocity. So I wanna maximize P, I'm gonna take the derivative of P. So I'm gonna take the d dy of both sides. Why did I choose d dy? Because you can choose, okay? It's because there are Y's over here, okay? So I'm gonna do the d dy of both sides. And right now I'm writing d dy, but eventually you'll just take the derivative of both sides, not even writing down d dy, okay? The derivative of P will be dp dy. The derivative of 20 minus Y times Y. I don't know if you guys see this, but this will be a product rule, okay? I'm gonna avoid product rule. The way I'm gonna avoid it is I'm gonna distribute this. Do you see that? So that's actually 20Y minus Y squared, okay? I'm gonna take the derivative of that instead. Does everybody see why I distributed? Just to avoid product rule. If you wanna do product rule, you can. It's gonna give you the same answer, okay? So the derivative of 20Y is 20. The derivative of Y squared is 2Y, okay? And then this is equal to the derivative of P. But always for the derivative of P, we're gonna set that equal to 0, okay? Why? Because if you think about our minimum velocity problem, to find the critical points, you take the derivative and you set it equal to 0. So we're doing the same thing. We're taking the derivative, we're gonna set it equal to 0. That's why eventually I'm not going to use this dp dy anymore. I'm just going to call it p prime because I'm going to set p prime equal to 0 anyway. So notation is not too important here. All right, so if I do this, do you see I'll get 20 is equal to 2y, so therefore y is equal to 10. So if y is equal to 10, guess what x is equal to? I can use this equation here because I know y is equal to 10. So it turns out x is equal to 10 too. So it turns out if I wanted to maximize the product, then x would be 10 and y would be 10. And let me make sure I answered the question. The question is to find the two positive numbers, and those are my two positive numbers, x and y, if I want to maximize the product. But guys, they didn't have to ask you what x and y was. What if I asked you, what is the maximum product? Could you tell me what that answer is? What's the maximum product? It'd be not 20. That'd be the maximum sum. What would be the maximum product? 100. Does that make sense? So I could also ask you, what's the maximum product? You'd have to tell me 100, x times y. All right. Now here's another question you might be asking, probably not, but if you were asking, hey, how did you know that that was a maximum and not a minimum, right? Because a critical point could be a maximum or a minimum. Remember, slope of 0, superhero, relative max, relative min, okay? So it could be a maximum, it could be a minimum. How did I know? Well, technically what you should do, which I did not do here, which you don't have to do, but I need to tell you that technically what you should have done was actually test it. You put p prime here, you find where p prime is equal to 0, okay? Right here, I set p prime equal to 0. That was when y is equal to 10, okay? I would put this equation into my calculator, okay? See that if I actually graph this equation at 10, this is actually a negative slope. So I would have gotten positive, positive, negative, negative. If I actually graph p prime, when p prime is positive, p is increasing. When p prime is negative, p is decreasing. And therefore, with this justification, I can say that I have a maximum here. This is the absolute max because I only have one critical point. Okay, if you have one critical point, then this must, and this slope is positive and this slope is negative, then this must be your absolute max. Okay, so FYI, for all of your problems, they're specially concocted. Okay, so that if they ask you for a maximum, so this is a maximum, you actually calculate the maximum without testing. If they ask you for a minimum, you actually calculate the minimum without testing. But in real life, okay, in real life, United better calculate if they actually maximize profit or minimize profit. Does that make sense? They better test it, okay, in real life, because if they don't test it, they might have thought they maximized profit, but ended up minimizing profit. Does that make sense? Okay, so, but in your life, which isn't real, you are not going to have to justify this. You just assume that what they asked you for is what you found, okay? So let's do another problem. You've got a rectangle. You want to maximize the area, okay? So just like the related rates problems, guys, it helps to draw the picture. And most of these, actually, I guess all of these problems, you're going to have a picture. The first one, we didn't have a picture, but this one, from here on out, you will. Okay, so draw a picture. You got a rectangle. You want to maximize the area. What do you guys want to call the length and width of the area? You like BH, LW, XY? What do you like? XY. Okay, so I like, if I do XY, I like to call my X's like the horizontal and my Y the vertical. It doesn't really matter what you do. Just stay consistent, okay? You have a maximum area. So I'm going to maximize the area. What is the formula for area? You have to think about this. What would your formula for area be? All right, XY. Okay, I'm going to have to maximize area. So I'm going to take the derivative of area and set it equal to 0. Find the critical points. But here's the thing. If I take the derivative right now, it's going to be implicit differentiation. So I'm going to go find some relationship I have between X and Y to avoid implicit differentiation. So I have another relationship here. The perimeter is 36. So what equation would that give me? Perimeter, 2x plus 2y is equal to 36, okay? This is my constraint equation. What this is I can solve this for x or y. It doesn't matter which one you do. Plug it into here, and then I only have an x or y here. I can avoid implicit differentiation, okay? So let's go ahead and solve for x or y. Which one would you rather solve for? X, okay? So this would be 2x is equal to 36 minus 2y, okay? That means x is equal to 36 minus 2y all over 2, okay? But this is the same thing as, because it's really 36 over 2. It's a common denominator, right? Minus 2y over 2. So x is equal to 18 minus y. Are you with me there on the algebra? Okay, now why did I do this? Because I want to get this into just one variable. And so if I know that x is equal to 18 minus y, I can replace this with 18 minus y. So what I get up here is maximum area is equal to the quantity 18 minus y times y. Okay, if I did that right, 18 minus y times y. Okay. After you know what you're trying to maximize or minimize, I've got an equation with just one variable. Can you tell me, what am I going to do next? Yeah, distribute. I'm going to take the derivative. But if you take the derivative, you're going to do product rule. Do you see that? And it's okay if you want to do product rule, you're going to get the same answer, okay? But it's a little bit easier, okay, if you distribute. So I'm going to say 18y minus y squared. Okay, I've distributed. Are you guys ready to take the derivative? Let's attack it. Here we go. That means a prime, I'm going to take the derivative, okay, is equal to, I'm going to take the derivative with respect to y. I just choose it. You can choose whatever you want. So that's going to be 18 minus, did I lose the y squared? Oh yeah, it's there. So 2y. Okay, is everybody good so far? Okay, you take the derivative, you set it equal to 0. Okay, solve for your y. That's going to be a critical point. So you get 2y is equal to 18. So y is equal to 9. Okay, if y is equal to 9, guys, I'm almost done. What is x equal to? X is equal to 18 minus y, turns out to be 9. Okay, this is just a coincidence, but what it really says, if you think about it, is it says if you try to maximize the area of a rectangle, you're going to get a square. Does that make sense? You're going to get a square because you got 9 on this side and 9 on this side. Okay, let's make sure we answered the question. The question says find the dimensions of the rectangle, and this is the answer. Y equals 9, x equals 9. Some students might say the answer is 9 by 9. Those of you guys are in construction or are used to construction, same answer, okay? What if I asked you, what's the maximum area? Because I could ask you for maximum area. What would the maximum area be? 81, okay? Everybody good with that? Now make sure you understand this. This is where students get confused. Do you notice that I did not maximize the perimeter? I didn't take the derivative of perimeter. Okay, that's because I didn't maximize perimeter. So guys, you can only take the derivative of what you're trying to maximize or minimize. There's 2 equations. Don't take the derivative of the wrong one. Is everybody good with that? I get students taking the derivative of the wrong one too. Okay, if they say maximize area, you want to take the derivative of area. Okay, all right. So problems are going to get a little bit more tricky. Not terrible, I don't think. I don't think we do any terrible problems. Oh, except for the parabola one. Oh yeah, and except for the semicircle one. Okay, all right, here we go, number 3. A rectangular plot is to be bounded on one side by a straight river and enclosed on the other 3 sides by a fence, okay? You got 800 meters of fencing, okay? What's the largest area you can enclose? All right, well, first we got a rectangle. So let me just go ahead and draw the rectangle, okay? That rectangle is going to have fencing, okay? But one side is not going to have fencing. So one side is a straight river, okay? But everything else is a fence, okay? We have 800 meters of fencing, and we also have maximizing the area. We're trying to maximize the area. So let me just write maximize, right up here, trying to maximize the area, okay? What's the formula for area going to be? Okay, x, y. So if you're saying x, y, then let's go ahead and label this x and y. So this will be x times y. Okay, if I'm trying to maximize the area, then I'm going to take the derivative of the area, set it equal to 0. Is everybody good with that? Same pattern every problem we did. Okay, I'm going to try to avoid x's and y's though. I only need one, x's or y's. I need a constraint. I need another equation. Okay, can you guys give me another equation with this 800? Kind of the perimeter. It's not quite the perimeter though. Yeah, it's 2y plus x equals 800. Do you see why it's not exactly the perimeter? Because it's not 2 x's, because it's just y plus x, okay? Now you're going to solve this for x or y. You choose which. You guys okay if I just choose x just because it's already kind of simplified there? So I get x is equal to 800 minus 2y. You're going to take that, you're going to push it over here. So that means everywhere I see an x, okay, I'm going to replace that with 800 minus 2y. So what I have is the maximum area is equal to 800 minus 2y times y. okay? And some people are like, okay, well, what happened? What would have happened if had I solved for y over here? Would I get different answers? You'd actually get the same answer, okay? So I know I decided to solve for x here and plug in for x, but had you decided to solve for y and plug in for y, you would have gotten the exact same answer. And the question is, how do I know? Am I going to do it for you? No, I'm not going to do it for you. You're going to go home. If you really are wondering, you're going to go home. You're going to sit in a closet. You're going to turn on the light. You're going to work that problem, solve for y, and see if you get the same answer, just for fun, okay? But I won't do it here just because I'm telling you, you will get the same answer. Okay, so you're going to maximize the area here. Don't forget to take the derivative. But before you take the derivative, what can you do to make your life easier? Distribute, okay? Now, once again, you don't have to distribute, but it will just make your life easier, okay? Once you do it, don't forget to take the derivative because this is a calculus problem. If you never take the derivative, then you never did the calculus, okay? So what I'll get here is 800 minus 4y, okay? What do I do next? Do you remember? Set the derivative equal to 0, okay? Solve for your y, so I'll get 4y is equal to 800. So my y is equal to 200, okay? If I know my y, can I find my x? Yes, so this would be x is equal to 800 minus 2 times 200, which is just 400 by the time I'm done. Okay, here's the hard part though. Make sure you answered the question, okay? So go back up to the question, and the question is what is the largest area? Okay, so what's the answer to the question? Kind of. 8 with how many zeros? 1, 2, 8 with 4 zeros. So whatever that is, 80,000, and that is your answer. And just like related rates, you don't need to put units unless they ask you for units. But just FYI, this would be meters squared. It's an area, right? Go find your length and square it. Okay, how are you guys feeling about these problems? You're okay with them? Okay, yes. So you mean had you solved for y here? No, like after you found y. After I found y was 200. Yes, I solved it. I plugged it into the perimeter equation. Yes, that's exactly. Because that perimeter equation is actually what we call a constraint. It's something that has to be true. Okay. All right. Here's the parabola problem. Here's the one you're going to hate. Okay. So the problem with this problem is really not that it's very hard. It's really just you don't know what to do. So you really just need to be familiar with the problem and you'll be fine. Okay, what it says is you're going to find the largest area of a rectangle, okay? The lower base of the rectangle is on the x-axis, and the upper vertices of the rectangle is going to be on this parabola, okay? And what is it saying? Basically, guys, go into your calculator and graph your parabola, okay? If you go into your calculator and graph the parabola, you'll have this picture. You'll know what the parabola looks like, okay? Then what you do is you draw a rectangle. The lower base of the rectangle is on the x-axis, okay? So the rectangle looks like this. You just need to be able to draw it. Once you draw, I think you're fine, okay? But students are like, how the heck do I draw this? Okay, so you just draw a parabola with an x and y axis, okay? And that rectangle sits like right here underneath the parabola, okay? This is your x and this is your y, okay? So I have a question. Maddie, can you see with your eyes closed? Okay, so I have a question. If I'm trying to maximize this area, right? So I'm trying to maximize the area, okay? What is the area? Close, very close. Okay, so let me show you why this is tricky. Call this point here, guys, xy. Do you agree that that point is xy? I mean, think about it. Like, this is a parabola, right? This is the x-axis, this is the y-axis. So this point would be xy, right? If I told you, and this is just a number, if I told you that this is 4, okay, what is the x value? 4. So what is the area of this parabola going to be? Yeah, do you see why though? It's 2xy. So this, right, do you see that this would be your y, right? But your x, you can't just say this whole thing is your x because on most problems we can define our x and y's. On this problem, your x must be from here to here. Like you don't have a choice because of the Cartesian plane, right? The Cartesian plane says that from 0 to x is your x. So your area must be 2xy. So this is the tricky part of this problem, okay? All right, so once I've gotten the area is 2xy, so I want to take the derivative of this, but remember I've got x's and y's here, okay? So this is my optimization problem. What is my constraint going to be? My constraint equation. I need another equation. Oh yeah, look at that. I need another equation that relates my x and y's. And it just turns out it's already here on my paper. Do you see it? So what do you want to do? Solve for x or solve for y here? Okay, so if you solve for y, it's already solved for you. Oh, by golly gee. Okay, so I'm going to go over here. I'm going to put it into my y. So that's going to be 12 minus x squared. Do you see how easy that is? Okay, as long as you understand it's already given to you. Okay, the constraint equation is given to you. All right, so then what you're going to do, again, just like the other problems, you're going to go ahead and distribute first. And again, just like the other problems, you don't have to distribute first. You can do product rule, but it's a little bit easier to distribute first. Okay, hopefully I distributed that right. Okay, what do I do after I distribute? Take the derivative. Guys, it is a calculus problem. If you never take the derivative, you never did the calculus, okay? What do I do after I take the derivative? Set it equal to 0, okay? When I set this equal to 0, what I get is 6x squared is equal to 25. So therefore, x squared is equal to 4. So therefore, x is equal to plus or minus 2, okay? And do you see where the plus or minus 2 is coming from, right? Because this is going to be your 2, right? And this is going to be your minus 2. Do you see where it's coming from? Plus or minus 2. All right. So what's my y going to be? How do I find my y? Yeah, plug it in right here, the constraint equation, right? So y is going to be equal to 12 minus 2 squared, because x is plus or minus 2. Doesn't matter if it's plus or minus 2, it'll still be 2 squared. So my answer here is 8. Okay, so y is 8. My x and y's are negative 2s, okay? So let's make sure I answered the question. The question is find the area of the largest rectangle. Okay, so this is your turn. What's the area going to be? It's 8 times 4, which is 32. Okay, do you see that some students will do 8 times 2? Do you see that some students do 8 times 2? But make sure you actually pull the whole width here, which is 4, not 2. Okay, you guys good with the parabola problem? All right, so I'll say that that's one of your harder problems, which isn't super hard, but it is something you need to know how to do. Okay, I'm going to do one more problem with you guys, and we're going to call it a day. You guys ready? This one's on page 4 of your notes, and or the back of the second page of your notes. Okay. So this problem might be useful. I think like if you had an English paper and you're trying to minimize your margins or maximize your words or something like that. When I was in English, I don't know, I made my margin so big, like my middle was basically just a vertical line of words, okay? But this here, I mean, they're designing a poster here, it's not really an English paper, okay? And what you want to do is you want to contain 50 square inches of printing. Okay, so make sure you understand, those are margins, and the printing happens right in here, right? Okay, you have 4 inches at the top and bottom. Okay, so let me draw this in for you, make sure this is right. 4 here, 4 here, okay? And 2 inches on either side. So 2 here, 2 here. I actually don't like the way this was drawn for you guys on the notes. I mean, I made the notes, but I actually don't like it because I copied it from another picture. And so what they did was they labeled this as your Y, is that right? So I'll keep it like your picture, but I usually wouldn't label this as Y. You guys good with that? And then they labeled your vertical as your X. Okay. All right. So the first question is, what is the overall dimensions that will, okay, you're trying to minimize the amount of paper used. Okay, so I want you guys to think about it. If you're trying to minimize the amount of paper, so this whole thing is the paper, okay, would you minimize area or are you minimizing perimeter? You're trying to minimize the amount of paper used. Do you have any idea? It's actually area. Okay, so just FYI. Okay, you're minimizing area. Okay, so what I'm going to do is I'm going to minimize area. Okay, but what is the area of this paper? Be careful. It's not just X times Y, because a whole paper is actually, see if this makes sense. It's actually X plus 4 times, no, that's not right. X plus 8, thank you. It's X plus 8 times y plus 4. Okay, is everybody good with that? Okay, I just want to make sure you guys understand. The mistake I just made is actually the mistake that most students make. They put the 4 and the 8 on the wrong thing, okay? Just make sure you label it very clearly and it'll be easy to read. Okay, then what you want to do is take the derivative of both sides, okay? But before you do that, you see you're going to have implicit differentiation here. To avoid implicit differentiation, I need another equation. I need a constraint, okay? Any idea? Oh, this is called the objective function. It just came to me. This function, what I've been calling the optimization function, technically it's called the objective function, okay? But we won't test on that. Okay, what is the constraint equation? Is there any number I haven't used yet here? The 50. Okay, what other equation does a 50 give me? What times what? X times Y is going to give me 50. Do you see that? It's the area that you're printing in. So I have XY equals 50. Solve for one or the other, it doesn't matter. I'll just solve for the Y. Okay, it really doesn't matter which one you solve for. Okay, if I know Y is equal to 50 over X, I'm going to come over here. Everywhere I see a Y, I'm going to put in 50 over X. Okay, so what do I get here? Minimize my A. Okay, X plus 8 times 50 over X plus 4. All right. At this point, you can choose to take the derivative. You can either do product rule or you can FOIL. I'm going to FOIL. It turns out whether you FOIL or whether you do product rule, they're both equally terrible. Okay, so you just choose what you want to do, what you want to terrorize yourself with. Okay, all right. So I'm going to go ahead and do product rule here. So let's see what I'm going to do. I'm going to take this X and I'm basically just going to FOIL it. I'm going to multiply it by these two terms. So that's going to be X times 50 over X, which just gives me 50, plus 4 times X, which gives me 4X. You guys with me so far? All right, now I'm going to take my 8 and I'm going to FOIL that. So I'm going to multiply it by these two terms. So it'll be 8 times 50 over X. That's really just 8 over 1 times 50 over X. So that's going to be plus 400 over X plus 32. Okay, and so the minimum A, I'm going to combine this, is going to be 82 plus 4X plus 400 X to the negative 1. Why did I rewrite the X to the negative 1? Because I know I'm about to take the derivative. So I'm trying to prep for taking the derivative. Okay, all right, so let's go ahead and take the derivative of this. And I just want to say that at this point, you've done so much that you think you've already zipped your pants. You know what I mean? Like you think you've zipped your pants, but you haven't, okay? So you really need to take the derivative, okay? So the derivative of A is A prime. What's the derivative of 82? 0. What's the derivative of 4x? 4. And finally, the derivative of 400x to the negative 1 is negative 400x to the negative 2, okay? And this is where things go awry. Okay, I'm going to set this equal to 0. You agree with that? And I need to solve for x. So what I get, I'm going to rearrange a little bit. What I get is 400x to the negative 2 is equal to, all I'm doing is moving this to the left, is equal to 4. Is everybody good with what I've done so far? Okay, what I do wrong a lot of times is when I move this over, I change this to a positive 2, but you can see you're not allowed to change this to a positive 2, right? All I'm allowed to do is add 400x to negative 2 to both sides. Any idea on how the heck I'm going to solve for x here? Multiply both sides by x squared, which essentially, see if this makes sense, and you're totally right, but which essentially is actually doing this. See if this makes sense. Changing this to x squared on the bottom. You agree with that? And if I have one fraction on the left and one fraction on the right, I can make this a fraction on the right and an equal sign in the middle. Okay, guess what I get to do? Cross multiply. Okay, so what I get is 4x squared is equal to 400. So x squared is equal to 100. So x will be equal to plus or minus 10. Okay, when you get this far, you're going to be thinking, okay, if x is equal to plus or minus 10, which one is it? Well, this is kind of like a geometry problem where you've already defined x as a length, right? So the negative 10 just goes away. X is just equal to 10. Okay, so I've got x is equal to 10. Can I find my y? Yeah, y is equal to 50 over x. That was from my constraint equation. So once you get your critical point from your minimizer and maximizing, then you come over here and you just plug it into your constraint equation. So you get 50 over 10, which is 5. So y is equal to 5, x is equal to 10. Make sure you answer the question. Okay, so I'm going to go back to my question. The question is, what are the overall dimensions of the paper? What are the overall dimensions of the paper? Are x and y the overall dimensions of the paper? No. So the overall dimension, see if this makes sense, it's going to be x plus 8 by y plus 4. X plus 8 by y plus 4. So I know my x is 10, so it's going to be 18 by, and I know my y is 5. I think that's 9 if I'm doing this correctly. Okay, and there's my answer. So if you get an 18 by 9 sheet of paper, okay, you can minimize the area, the overall dimensions of the paper, amount of paper used. Okay, any questions about that? Do you like optimization? It's not bad. Okay, good. So your homework, guys, is problems 1 through 8 on my math lab. If you have